Acid-base reactions. Soda contains two weak, I think this is a Midwest thing here, or upstate New York. Soda contains two weak acids, phosphoric acid and carbonic acid. There's a couple of different definitions of what are acids and bases. First, we'll look at the Bronsted-Lowry definition. It defines an acid that will donate an H+ ion and a base that will accept an H+ ion. So we have ammonia here. You can see it has room over here to take in another H+. So this would be a base. Now water can donate an H+, and that means that water would be an acid under this classification scheme. So you can see what you get out here at the end, ammonium and hydroxide. So water in this case is a Bronsted-Lowry acid, and the ammonia would be a Bronsted-Lowry base. The Lewis definition talks about an acid being an electron pair acceptor and a base which would donate an electron pair. So here we have ammonia, this guy over here. He's going to react with this molecule, and the R just means there's other stuff there. It's another part of the molecule. The important stuff, erase that again, is happening right in here. This hydrogen breaks off, and you can see how we have two electrons over here. They're going to go here. It's going to donate a pair, and this hydrogen bond is going to switch from here to here. So we wind up with an ammonium ion, and then this item over here, and can't tell what it is because this R is a bunch of other elements. So in this case, this is your base, the ammonia, over here, and this is your acid, the CO2 plus other elements. Bronsted-Lowry acid-base reactions involve the transfer of H+ ions, hydrogen ions, from one acid, which is the H+ donor, to a base, which is H+ acceptor. So over here, we have acetic acid. Here, we have the carbonate ion. They react, and we get a bicarbonate ion. And over here, we have acetate. So what's going on? This guy right here, the acetic acid, gave away its H+. That means this is an acid. The carbonate ion here accepted an H+. That makes this the base. So here's the acid, here's the base, again, according to the Bronsted-Lowry definition. Identify the acid and base in the following reaction. So take a couple seconds working on your own, and you can pause the video, and when you're ready, come back for the answer tab. Okay, here we go. So what do we see here? We have Cn over here accepting an H+. See how it becomes HCN? So that is a base. Water donates an H and becomes hydroxide ion, so it is the acid in this case. Seems funny to think of water as an acid, but it is by this definition. Identify the acid and base in the following reaction. So take a couple seconds, pause the video if you need, and we will open up the answer tab here shortly. Okay, so let's try it. We can see how the HCO3 becomes H2CO3. So it accepts an H+. So here's your base over here. The hydrogen fluoride here donates an H+. So this is an acid. Neutralization reactions are a special type of acid-base reaction in which an acid and a base react and they produce water. So here's our acid, hydrogen fluoride. Here's our base, hydroxide ion. They combine, they form water and a fluorine ion. That is a neutralization reaction.